everyone. This video is directed at the electronic hobbyists and people using like Arduino and Raspberry Pi and that kind of thing. And there's a lot of popular YouTubers out there that are spreading disinformation, whether they knowingly do it or not. And I want to correct some of that. Turns out the misuse of electronic symbols can not only cause problems, it can also potentially cause danger. These are the two organizations responsible for terminology and symbols used in the electrical and electronic areas. This is the Institute of Electrical and Electronic Engineers. Right away, we see there may be some difference between electrical and electronic, and we'll get into that here in a minute. This is the International Electrotechnical Commission, and together they serve many countries in the world and homogenize terminology and symbols. Now, when we talk about the electrical world, that would include things like power generation and distribution and mining and manufacturing. And then we have the electronic world. And this is primarily AC, but it can also involve DC. And this is primarily DC. And this would be general electronics and audio and things like that. Now there's this overlap area here where both the electrical and electronic worlds overlap. And this would be things like power supplies, microwave ovens, industrial electronics, and so forth. And generally the home hobbyist falls in this electronic area. And but because they have to get DC power somewhere, this area here gets involved. And even when you're working in this area, you need to know some things about this area. And that's what we'll get into next. This is a resistor, and this is symbol for a resistor. This is a capacitor, and that's the symbol for a capacitor. And this is an NPN transistor. And that's the symbol for an NPN transistor. Now you wouldn't use a capacitor symbol for a resistor or vice versa, but there's a symbol that's constantly being misused, and that's what we're going to talk about next. This is a ground rod. It's a copper-clad steel rod, 8 feet long or 2 meters, driven into the ground. And in this particular case, it's for grounding the building. The cable there runs up through the concrete and connects to the steel girders that support the building. There are 4 of these ground rods, one on each corner of the building. This is the symbol for a ground rod, and it can be used to mark terminals where a wire should be connected to make its way back to a ground rod. And there's 2 other symbols that you should know. This is a symbol for the connection to an enclosure or a chassis, sometimes called the crow's foot. And then this symbol is an equilateral triangle. That's the correct symbol for a circuit common. And in a mixed signal board where there's digital and analog and power, you can often separate grounds and connect them at one point. And so you might have a common for the power circuit and a common for the digital circuit and a common for the analog circuit. So these commons may or may not be connected to a chassis or an enclosure or to ground. And there's a circuit common that may go to a chassis or an enclosure and then go on to ground. And that would be the way to show it. Well, now that you know what this symbol means and what it designates, it certainly wouldn't make sense to use that symbol on a electronic circuit that's used on a drone or a radio-controlled airplane or any kind of vehicle, actually. So let's talk a little bit about where this really is used, and that's in the AC power system coming into your building or home, and the grounding and earthing of the AC power system. You really got to understand that for your own safety. Also, this relates to test instruments, common things like oscilloscopes and function generators, and I'll show you the importance there. Also, with power supplies, some of them are grounded, and sometimes you have the option to unground your power supply. And I'll talk briefly about electromagnetic interference from switching power supplies. This can be a big problem when you're working with sensitive analog circuits. Also, when you're powering a Arduino or any kind of a circuit from a USB coming from a computer, you may or may not be grounded, and I'll show you how to determine that. This diagram represents a typical electrical system in a house or a building, and it's just to show things in general and not be highly specific. Generally, somewhere there will be a transformer either mounted on a pole or a pad, or some cases even underground, and it'll be fed by relatively high voltage. This voltage depends on how far you are from your nearest substation. The secondary of that transformer is actually 240 volt center tapped, where the center tap will run to earth ground. And of course, the case of the transformer is also connected to the ground. This is sometimes called the 3-wire Edison system, where you have 240 volt center tapped. And that'll run to your electric meter. And of course, that'll be running back to ground, the enclosure of the meter. And then the 240 volts in the center tap will run to your load center. Sometimes it's called the control panel or the breaker box, and there's many slang terms for that. And in the load center, circuit breakers can be snapped in to feed various loads. And a 2-pole breaker, when that's snapped in, it makes connection to the 240 volt, and that's for feeding things like air conditioners and water heaters and so forth. So here we have 2 lines and a ground, and the ground is connected to the enclosure in case one of these lines should accidentally fall off and connect to the enclosure. So lights and outlets and so forth are fed in a similar way, except these are just fed from one rail or the other, and that's done to balance the load between the 2 feed lines. So a typical outlet will have a line coming from a breaker, the neutral, and the ground. And here in the US, this is a typical outlet. The ground terminal is designated with a green screw, and the neutral connection is silver screws, and that connects to the wide slot here. And the line, or the hot wire, goes to the gold screws, which is connected to the narrow slot. So this pin here also connects back to the ground wire. So notice the symbol here for the ground. There's a main ground rod that connects to the rails here, your terminal rails. And one of these is actually connected to the enclosure of the load center, and the other one is connected also to that rail. So that's the symbol for an earth ground rod. That's a symbol for an earth ground rod. And here's connections to enclosures. So that's how these symbols are used on your electrical system. Here's the ground rod for the electrical system in this building. The heavy black wire is what connects to the ground terminal strip inside the electrical box. This wire is the auxiliary ground wire for systems like cable TV, internet cable, and telephone systems. This is my workbench / laboratory. I have a scope and a function generator here, soldering iron, meter, couple power supplies, and let's find out what's grounded and what isn't. This wire here is the ground conductor of a normal 3-conductor cable that's plugged into the outlet strip there. And it just gives me a convenient way to make connections to ground. So let's find out what's grounded and what isn't. There I connected one side of the ohm meter to our ground connection. And let's look at the oscilloscope first. Is the oscilloscope grounded? If I connect to it there, yes it is. There I came off of it. So what I'm doing is connecting to the conductor of the probe, the outside conductor of the probe. So that's grounded. What about the function generator? If I connect here, well, I just get kind of random stuff. When I see a negative on an ohm meter or on an ohmage reading, that usually means there's some voltage involved. So I would say this function generator is not only not grounded, it's producing some voltage. And what about the soldering iron? Okay, this does not appear to be grounded, but what about the iron itself? I didn't get on it there very well. I'm having trouble doing things with one hand. Okay, so the soldering iron appears to be grounded, although there is some impedance involved. That could be just due to corroded connections. But at any rate, there is some fairly low ohms to ground from the soldering iron. Now then, what about these power supplies over here? Here's the common wire on that power supply. That's not connected to ground. The plus terminal is not connected to ground, but there's a green terminal here, and that is connected to ground. And we'll find the same thing on this supply. No connection to ground for the voltage output, but there's a green terminal here that is grounded. And notice there's a link here where this can be connected to the common so that the actual output is now grounded. There we have some ohms because we're looking back through the electronic circuit. So there's some mysterious things going on here, like this function generator. So let's look at that more closely. Okay, I turned on the oscilloscope and the power supply, and now I'm going to connect the scope to the common lead of the oscillator. And this is on 50 volts per division. So we can see that we have considerable AC voltage between the common on the function generator and the common on the scope. And this function generator is powered from a wall wart, which just has 2 pins, so of course it can't be grounded. And there must be some capacitive coupling that's generating that voltage there. Now when I load that down by putting my hand between the scope common and the probe tip. You can see it goes down just due to the resistance of my skin. So it's a high impedance, but it's the kind of thing you need to be aware of when you're working with analog circuits. You can't just go connecting the oscillator anywhere in a circuit. You probably have to use the ground wire to the circuit common of anything you're working on. So that's just a little thing you need to be aware of with these type of devices. Okay, I've turned on this power supply and I've connected the scope to the ground terminal, which is connected to the common terminal for the output voltage. And the common of the scope is connected to our building ground. And let's look at the oscilloscope, and that's 1 volt per division, and you can see all that hash. Now I'll expand it, and you can see it's short transients. That's the switching transients that are generated by the switching power supply. So that type of power supply, although it's impressive, it can put out 10 amps at 30 volts. It's extremely noisy, and is really it can't be used when you're working with analog circuits. This similar size power supply is only good for 1 amp at 30 volts, but it's very quiet. So again, these are some things you want to think about when you're working in your home laboratory. So when you're working on an Arduino, is the common of the Arduino board connected to ground? Well, the answer is yes and no. If you're operating it from a desktop computer with a 3-prong power cord, then the answer is yes, it is grounded. However, if you're operating from a laptop, either from the batteries of the laptop, or some laptops have 2-pin power supplies, so even if you're operating from AC power, if it's got a 2-pin power supply, then you're not grounded. So just some more things you should know about grounding, when you're grounded and when you're not. Well, I hope you understand the special significance of that symbol and how these 3 symbols can be used together. When you see a video where someone is misusing that symbol, perhaps you can send them a comment and let them know so they won't keep doing it forever. This outlet strip in the back of my workbench, as well as this one here, are powered from a ground fault circuit interrupter that's in the breaker box that feeds the outlet that these outlet strips are plugged into. I hope that all makes sense to you. And a ground fault circuit interrupter can protect you when you're working on any type of AC power device, like a power supply or an electric heater or a humidifier, you name it. And I highly recommend you make sure you're using a ground fault circuit interrupter. Now they also come like this, where you can plug a single device into them and then plug this into an unprotected outlet strip. So I'm going to demonstrate how that works here shortly. And a ground fault circuit interrupter is also available like this for use with extension cords for outdoor use. Maybe you're using an electric hedge trimmer or weed whacker, something like that. This would give you ideal protection if you're working in your bare feet on wet ground. So I'm going to demonstrate how these things work. If you really want to see the internal circuitry of a ground fault circuit interrupter, there's a video listed below that you can look at. This is an ordinary 3-conductor power cord, and I've stripped the ends here, and I've connected a neon lamp through a 47K ohm resistor between the hot lead and the neutral lead. And of course this is the ground lead. I'm going to plug this in to our ground fault circuit interrupter and reset the device. So there you can see the neon lamp is illuminated, and right here I have a 1000 ohm resistor which I'm going to connect between ground and the hot lead. And you see the power is instantly disconnected by the ground fault circuit interrupter. So I'm going to reset that again, and you see we have power. Now, what if you get between the hot wire and the neutral wire? Well, I think you can tell you don't want that to happen. So, connection between ground and the hot wire will trip the ground fault circuit interrupter, but if you get between the hot wire and neutral, it will not. So although this can save your life if you're accidentally grounded and don't know it and touch the hot wire, but if you get between the hot wire and neutral, it will not. So be very careful.